Purpose of today's lesson is really to be able to read a word problem with given information and to construct a number of equations to represent the quantities in that equation, and then use matrices to solve for the unknown variables. All right, so we have two different examples we're going to look at today. Number one, you have a high school basketball game. They have a number of things listed here. First of all, we know that there was 452 tickets sold. We know that the student ticket's 75 cents and the non-student tickets are $2. The question is, how many tickets of each type were sold if the revenue for the sales was $429? Right? So one of the very first things whenever you're working problems like this is to define the things that you're looking for, right? So we're going to let X be the number of student tickets, and we're going to let Y be the number of non-student tickets. Okay? If I can define the unknown here, the things I'm looking for, it helps me to write out my equations. Okay? Since I have two unknown things, then there needs to be two quantities for me to write an equation about. I have to have two if I'm going to solve this. In this case, we do. We have tickets, the number of tickets, and we have something about money, right? Two quantities. So the easy one is, well, if I sold so many student tickets plus so many non-student tickets, that would be the total number of tickets sold, period, right? That's 452. The next part is about money. If I know that the total amount of money was $429, then I know that if I multiplied the price times the number of tickets and added them all together, that would equal the total price. So 0.75 times X plus $2 times Y equals $429. And that's exactly my two equations. What I want to do at this point, actually in most scenarios, that's the hardest part, okay? I want to be able to take this and turn it into a matrix equation and then use my calculator to solve these different equations. Now this one we actually know how to solve by hand, but really what we're really getting into this part, it's not necessarily that piece of it that I'm trying to test you on. It's can you take the information and can you come up with the equations and create the matrix equations with it? So in this case, we're going to write out our coefficients of 1, 1, 0.75, 2. We have our variable ones next, X and Y, which is equal to the 452 and the 429. Okay, now in basically when we work these out by hands, this is matrix A, this is matrix B, of course this is just X. In order for me to get rid of this, we have to multiply the inverse on both sides, right? And so what we're going to do is we're going to type this into our calculator and we're going to solve that system of equations. Once I've solved it, I get xy on this side by itself because the inverse cancels out. And when you multiply the inverse times matrix B, we end up getting the following numbers. We end up getting 380 for X, the number of student tickets, and 72 for the number of non-student tickets. Number 2 is a lot more to worry about. This one's actually rather complicated in some ways. It's not terrible in others, but we're going to go through it and try to get rid of this. All right, that's better. A florist makes 5 identical bridesmaids bouquets for a wedding. She has $610 to spend and wants 24 flowers for each bouquet. Roses cost $6, tulips $4, lilies $3. She wants to have twice as many roses as the other 2 flowers combined in each bouquet. How many tulips, roses, tulips, and lilies are in each bouquet, right? So let's make this easy. We're going to let R be the roses. We're going to let T be tulip. And we're going to let the L equal lilies. Okay. Now, here again, I have a number of flowers, right? We want 5 bouquets, that's important, and we want 24 flowers in each one. That's a lot of flowers. So if I think about it, if I took the number of roses plus the number of tulips plus the number of lilies, that would be equal to 5 times the 24. Right, so 5 times 24 is 120. So I need 120 flowers total to make this happen. The next thing they talked about was price. Right, well that's actually relatively easy. I think that of all of them is the easiest one. You have $6 times the number of roses plus $4 times the number of tulips plus $3 times the number of lilies. And that's going to be equal to, now I can use, let me change that. It looks like a 1L. Okay. Equals the total amount of money that I have to spend is $610. It'd be great if I could make that work out exactly 610. In real life, that's probably not going to happen, but just go with it. In this case, I have to have one more equation. Remember, I told you that for every variable you have to have at least one equation. So I've got an R, a T, and an L. Well, that's 3 variables. I have 3 equations. There's one more thing that we haven't done anything with, and that's the part that's probably the most confusing. It's this piece right here. We want to know the number. She has twice as many roses as the other 2 flowers combined. So that means the number of roses is equal to 2 times the other number of flowers combined. And so if I think about what that means, literally as it's written, it's telling you R equals twice the others combined, right? So you see that kind of, the number of roses equals or is 2 times as many as the other 2 values combined. And that's exactly what we did here. And so we have to come up with a way to put this into a matrix. One of the most important rules is when you write it out, you have to have every equation in the same order. Now, so R, T, L equals constant. So I need to rewrite this equation. We're going to go ahead and distribute and rearrange it. So R equals 2T plus 2L. I'm going to rearrange this so that I have it every letter on one side. So we're going to basically have R minus 2T. Let me write this over here. It'll be R minus 2T minus 2L equals 0. Right, so we have 1, 2, 3 equations that we can use to work this out. I'm going to go ahead and write the matrix equation for this. This is a 3 by 3, so we don't even know how to do this one by hand. So we're going to have 1, 1, 1, 6, 4, 3, and then we have 1, negative 2, negative 2. The variables that we're working with are R, T, and L. Notice that I'm keeping them in the exact order that we worked in. If I rearrange them or get them incorrect, then my solutions will be off. That's 120, 5 times 24, then 610, and 0. Right? And let's be really clear. This piece here is that's the new part. This is the part I'm really checking to see how well you can do. Can you take a situation and write out your equations to model this? I think once you're here, getting it into this form and working it out, even in the calculator, is usually a relatively easy thing to do, right? So if we finish it out, we're going to have R, T, and L equal to, let's see, if we solve this situation, we have 80 roses, we have 10 tulips, and 30 lilies. Okay? Now that's for all together. If we talk about what's in each one, this is not really an issue. Oops. If we think about it this way, in each bouquet, if I had thought about it, if I had asked this question, that means I would have 16 roses, I would have had 2 tulips, and I would have had 6 lilies. Now, if we think about it, the number of roses has to be twice as much as the others combined, right? So 2 plus 6 is 8. 8 times 2 is 16. Totally works. We also know that we wanted 24 flowers in every bouquet. When we add these things together, you get 24. So this is a way that we can work with information. Now, this is kind of a simplistic idea. I mean, this is not an easy question, but We're not working with really complicated processes. And I can work this out, I can organize my information, and I can, without having to do any kind of guessing and checking, I can just set it up and say, here's what I've got, let's see where this works out to be, and it'll give me those kinds of situations. I hope this helps with how to write out equations from given problems with given information. If you have any questions about this, let me know, and we'll talk with you later.